All right, so onwards we go. More and more limits. The limit as x approaches infinity, so now we're doing a limit at infinity, of a fraction, x squared plus 2x divided by the quantity 2x squared minus 2x plus 1. When we talk about fractions here and we're doing a limit at infinity, this is one of those ones where we're going to want to go ahead and find the highest power in the denominator, and that's 2. So we're going to divide each of these 5 terms here by x squared, reduce them, and then see what happens as we let x get very, very big. X squared divided by x squared, 2x divided by x squared, 2x squared divided by x squared, 2x divided by x squared, and 1 divided by x squared. As long as we're dividing everything by the same thing, we're essentially dividing by 1, and that doesn't change anything. So when we reduce this, the fraction on top becomes 1 plus 2 over x. On the bottom, it becomes 2 minus 2 over x plus 1 over x squared. Now we can go ahead and do the limits of each of those 5 pieces. The limit of 1 is just 1. The limit of 2 over x as x gets big is just going to be 0. The limit of 2 is just going to be 2. 2 times the limit of 1 over a large number, well, that's going to be 0. And so is that last term. 1 over a large number squared is also going to be 0. So what we're going to be left with is 1 plus 0 on top, and on the bottom, 2 minus 2 times 0 plus 0. That's just 1/2. If we were to look at this graph, what we would see as we move farther and farther to the right, we're getting closer and closer to 1/2. In fact, what this is showing is this particular graph has a horizontal asymptote, which I've put in right here. When you do limits at infinity and you get out a value like 1/2, that's basically telling you where the horizontal asymptote is in a graph. So this is your strategy now for horizontal asymptotes. We've looked at graphs to do this before, but now what you can do is take the limit as x approaches infinity, as x approaches minus infinity, see what it equals, and that tells you what your horizontal asymptote is now.